Chapter 8.2 Modeling Assumptions. According to the modeling process, that the second step is the modeling assumptions. Uh, you can see certain words in the sums, then you have to assume certain things with these words. So we are going to certain concept with this word. So we are going to discuss what it is. The first word I'm going to discuss with the string. So with the string, you can see that they add an adjective is light string. According to your sense, that what is the difference between a string and a light string? So in a light string, the mass is disregarded. Mass is disregarded, or mass is zero. And also, we another thing we assume the tension in the tension at both ends are same. When you pull a mass from a string, uh, we are pulling this mass from a string. So then the string we regard as a light string. It means the mass is zero, and the tension at the both ends are same. So this one, what will happen if you pull a mass, or if you pull a table, or if you pull anything with a string? You feel that this object feel that they are pulling like this, and this person feel that he is pulled by this. That's what happen when you pull uh, uh, something mass with a string. You can do that, and you can feel it. So this object, you feel that he is pulling this direction. At the same time, this person is feel that he is pulled by this object. So then that for that force, the tension he feel is like in this direction. So we will put T, and this is T. The tension at the both ends are same. So this is the meaning of this one. Or sometime it goes through a pulley. This is a pulley. So at the same time we have to give one more. This is a small pulley. Then the tension is going to be same. This is the pulley is feeling, and maybe there may be a mass is attached to here, and this is a table, and another mass is, or a particle is hanging like this. So this is T, and this is T, given that the pulley is smooth. So basically, if we use light string, then two things we have to think: that mass is disregarded, mass is zero of this string. We are not going to mark the mass of this one, and tension at the both ends are same. The other word is inextensible string. It's not elastic. So the assumption is here the same acceleration in the objects connected by same acceleration. Assume a one, two masses connected by a string. This is inextensible, and this is elastic one, stretchable one, extensible one. So this is M, 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 M. Assume that when you pull this one by with the force F, and assume that what will happen when you start pulling this one, this will start moving. At the same time, this one is start moving. But if it's elastic one, what will happen? When this will start moving, this is at stationary. After some time this will start because this is the elastic one, extensible one. Because of that, the acceleration of this part is different to the acceleration of this part. In A-level mathematics, we don't consider the two masses combined with the elastic. So only we consider with the inextensible uh, string. And the tension at the board ends also same. So this object feel that uh, this object is pulled by this string towards here. At the same time, this mass feel that it is pulled by this string towards here. You can see that if we want to feel, so go to a baseball court and then put a rope, tie a rope and try to pull this rope. You feel that you are pulled by rope towards here, towards this direction when you try to pull this ball. The second word is rod. What is rod? Not rod, rod. You can think about a thing rigid, straight, straight bar, and yes, basically the assumption is no bending. Um, you can see sometime with the rod the adjective light rod. Light rod mean you know already, not heavy. Uh, so disregarded the mass. Mass is disregard. The other one is uniform rod. What is the idea behind in uniform? It means mass is distributed evenly. What is the meaning of mass is distributed evenly? Assume this is the bar, and if it is let's say 20 kg, then it is act on the middle 20 kg. Assume the same bar, if I break into a two pieces, equal two pieces, then this bar size is 10 kg and this bar size is 10 kg, because the mass is distributed evenly across the brain. So idea behind uniform is the mass is distributed evenly, anything. So as a result, when something, the mass is distributed evenly, the center of mass is in the middle. This is x distance and the same distance from here. But if it is not uniform, the center of mass is in sometime is not somewhere here, not in the middle. Good example is if you take cut a stick from a tree, and let's say this is x area and this is y area. So you cut a stick or a pole from this tree, and so this is the x area and this is the y area, and you will see that always this area is heavy, and rather than this area, because lot of new stations around this area. So hence the center of mass does not stay in the middle if you cut a stick or a rod from a tree. In some, we can see that the rod is used to connect two masses. Instead of rope, we can or a string, we can use a rod. So it's going to be a tension that if it's pulled. Sometimes we use a rod to push something. So we are um, pushing this mass. The direction of force is in this direction, then usually we call it is a thrust. And so here tension T, we can write the force is as P, and the person who is pushing will feel that he is pushed by this one. So that's how we will discuss in the next section, that thrust and the tension. So this is the direction of the thrust. Sometimes we keep the rod on the pegs. We will see that when we work with some sums. So, and if it is a uniform, the mass is in the middle. The weight act in the middle. Third one is I'm going to discuss particle. In here, instead of a ball, uh, assume we keep it a football in an inclined plane. Instead of that, we are referring as we are keeping a particle. Can you guess one thing we disregarded here? We disregarded this is the ball. We disregarded the dimension. As a result, what will happen? So instead of a big ball now, it is just a small particle. Now, again, one more thing we disregarded. No air restrictions or no rotational force. No rotational force. If a ball is or apple is falling down, then there is a air restrictions. For example, if if wind come to this direction and if we run towards this direction, we feel that the wind is pushing us towards this direction. So that is uh, air restriction, air resistance, air resistance. And the other thing is mass is concentrated on at single point, uniform in the middle. For example, if the particle is here, we can mark the weight as mg. This is the inclined plane. Fourth one is surface. The, the adjective come with the surface is smooth surface or rough. When you look at a surface, this is the board surface I'm touching, and the road surface. Which one is more rough? The road surface is rough than the board surface. So what is a smooth surface? Smooth surface in other way, the roughness is 0. That's what we refer as a smooth surface. This roughness or rough is caused for what? For a friction. If the surface is rough, there is a friction. If the surface is smooth, no friction. This is the assumption you want to make. So if it is a rough surface, there is a friction. If it's a smooth surface, the roughness is 0 mean 0. It means no friction. If you try to pull 10 kg 10 kg in tile floor, so and if we try to pull 10 kg in a road, so the tile floor is much easier to pull, but the road is difficult because of the friction force. The friction force act against the moving direction. If we try to pull this direction, the friction force is acting on the object opposed to the moving direction. So this is called friction force. And assume this is a smooth surface, then there is no friction force. Usually we don't mark the friction. Or a particle in a smooth flow, smooth inclined plane, then only it will act on mg, the weight. But if the particle is in the rough plane, this plane is rough. So what will happen? Mg also act. There is another force. The ball is moving to this direction when we release. So another force acting opposed to this one. This is along the along the line, along the plane, but we'll mark it here. So that is called friction force. The fifth one is head. So it is something. It's a ring basically moved freely along a wire or a string. Something like this. This is the ring, and it's going through the. This is a wire or a string. The important thing is here, because of this weight, uh, this wire or the string create a tension, and this tension is the tension is same before this point and after this point. For example, this is the touching point, the left side of the touching, from the touching point to the left side of the string, and from touching point to the right side of the string. So those are the two sides basically. um, the tension is equal. The same thing we refer as sometime ring, but smooth ring. If you see the word smooth, means it's taking out the roughness. So as a result, we are losing that friction. So when we lose the friction here, what will happen? The tension is going to be equal. Otherwise, what will happen? Uh, this tension is T1 and the other tension is T2. So if the word is beat, then the main idea behind this one is the tension is same in both sides of the string from this point, the touching point. The sixth one is peg. It's a support. With a body can be suspended or rested. We can keep a beam on two pegs. There are two types of pegs. One is smooth peg, other one is rough. And here the word smooth will make the tension same. Likewise for a peg, what kind of changes it makes. If it is a smooth peg, then the isoforce will learn the normal force in the next section. Both are same. If it is rough, then this is going to be R1 and this is R2. We have to mark differently with the different symbols. So this is R and R. The both forces are same. So that is the difference with the smooth peg and a rough peg. This is how we usually mark the peg. Uh, it's with a small triangle. The other one is pulleys. We only consider here pulley. You may see in sometime in a table fixing like this, like so, or sometime we can use a pulley. So this is a pulley, and this is a string to lift something. So this is a pulley. So we only consider smooth. So what is the idea behind the smooth now? It means this tension is not a two different tension, so it's going to be the same size. Tension is same and light. So you know what is the meaning of light mean? We disregard the mass of the pulley. So smooth and light pulley. We don't discuss in A level that the rough and heavy pulleys. So smooth and light pulley. So with the smooth, uh, the tension is the same. The tension is the same on either side of the pulley. With the word light, mass is disregarded. So with this bead, move freely, move freely along the wire or string, and the tension is the same on either side of it. Let's discuss exercise 8b now.